Okay, welcome to this tutorial, which is going to cover the modelling of this part of the tow bar assembly, commonly referred to as the tow ball. First thing you need to do is to study the information that's given to you to work out a plan of attack. Before we even get that far though, we can see the name is ball MS. MS is an abbreviation for mild steel in comparison to spring washer SS, sprung steel, MS again, and so on. So it's important to familiarise yourself with that technical vocabulary. Anyway, the shape of this tow ball is what we're after. So let's have a quick look. Main features here are we have a diameter 50 spherical shape for the ball. Makes sense, it's a ball, it's a sphere. And the important thing to note here is that this dimensions that are coming off this area here, this is the centre of that sphere. So the distance from the centre of the sphere there down to this top edge is, no, stupid thing, to that top edge there is 38. The thickness of that section there is 12, and then the length of the threaded section, or almost the full length, is, I think it says 58 there by the looks of it. So there may be a temptation to try to draw this with extrusions. I find the easiest way to draw anything that has a spherical shape on it to do it as a revolution. So imagine we cut the ball in half, like a vertical plane cutting through it, and we're going to draw a quarter, if you like, of what we see, or half a section, and revolve it around a center point. So to do that, let's go over to Creo. Remembering that this is 50 sphere, we can start with that. So over to Creo, and there's a finished one. And as you usually would do, File, New, make sure you're putting all these parts into one folder. Actually, I might even do that right now before I go any further. I might go File, Manage Session, Select Working Directory. And I'm going to change it from my 2014 classwork to 2015. And I'm going to create a folder here, so I can simply just right click, New Folder, and I'm going to call this one tow bar 2015. So all these parts will go into a new folder in there. Click OK. So now my working directory is set. So let's now go File, New, and let's create a new part, and let's call this the tow ball. Remember, no spaces. Tow ball. OK. OK again, and obviously present it with a blank screen. Turn your planes on. I tend to always draw my section or profile on a plane that's going to be in the correct orientation. So I'm going to choose this front, or I could have chosen lateral plane, doesn't really matter. Front, put a sketch onto it. And the first thing I'm going to draw a circle that represents that spherical shape. So I'm going to go to Circle Tool, come down to the intersection of the axes here, and click once, move away, click again, and then click on my arrow to see how big it is. 50 millimeters in diameter. Remember, Creo measures everything in diameter. Remember that when you're looking at radius. Okay, so there's my 50. Back to my PowerPoint. It tells me that the distance from that center down to this edge is 38, and another 12. So these edges that are going around the outside here are going to be parallel to that horizontal line. So I could possibly put two lines in to represent those two edges, 1 and 2. So what I might do is go over to Creo and just using my line tool somewhere down here, I don't really know where just exactly yet, I'm going to draw 1, 2 lines in, and then I'm going to dimension those appropriately. So I'll pull these dimensions out, 1 and 2, so that was 12, I think, between those two, and I think that was 38. I think, gee, that was close. 38 and 12. Let's go back and check. 38 and 12. Wow, that was close. Okay, so now let's get some geometry that joins the spherical shape to that line there. So we can see here by reading on the drawing this smallest diameter of this part underneath the sphere here is a diameter of 30. So if we're working in 2D, we've got to remember, of course, that means if I was from one side to the other side it would be 30, but I'm just going to draw a line down here to represent that position. So I'm going to go there, and you notice I'm not snapping at anything, I'm just drawing a free line there. And the distance then from the center to that point needs to be half of 30, which is 15. Now here's something you may or may not be aware of. If I double click and I want to make that exactly half of 30, if I type in 30 /2, so divide by 2, hit enter, and there we go, it makes it exactly 15. Alright, so we're getting the shape coming around there, dropping down, out, so we need to finish it off here. Back to our PowerPoint, and we can see here the diameter at its widest point is 50. So at that point we know from the middle to the outside must be 25, so I come back to Creo, and once again line tool, somewhere out here in existence, draw a line, and once again let's find the dimension from there to the center. So I'm just going to put that dimension in using my dimension tool, from that line to the center, snap down here, and that needs to be a distance of half of 50, which is 25. Well, I could have done that /2 thing. Right, let's clean up this a little bit, get rid of a lot of this excess lines that are here, and we don't want anything there, we don't want that, we just want the outline. So there, and we only want it on that side. So now what I've got is half of that profile. I'm not worried about this radius in here or here. Best to do those with your round tool after it's a solid. Double check 25, 12. Okay, that 10 disappeared, but if you wanted to, you could check it. You go from there to there. 15, which is correct. 18 just happened to be random size, so we could check that as well by going normal from the center to here, which is 38 again, which is correct. That's looking good. Now you notice I've got red dots, so I do need to complete that section. So use my line tool, I click once, I click twice, and if I now go arrow, this should fill in, which it does. There's no red dots. There's shaded, which indicates it's a closed sketch. And also always click on your overlapping geometry to make sure there's no purple lines appearing, means you haven't drawn a line over top of a line. Now you're almost ready to revolve it. The only thing you've got to do before you revolve it is you've got to put a center line in. Now have a look up here in the ribbon bar, there are two center lines. One on the left here, 2-point geometry center line, one on the right here, 2-point construction center line. The revolve tool only recognizes a center line that is a geometry center line. So click on center line, and I'm going to revolve it around this center line. So I click once, I click twice, and now our center line is in there. Let's accept that sketch, and let's go then to revolve tool. And because there was a center line there, whoa, just lost it. Because there was a center line there, it immediately assumed that I wanted to revolve it around that center line, and of course the angle being 360. Of course there are other options. You know, if you don't want to go 360, you can use it to cut, you can do it as a surface. It's always a dead giveaway if this doesn't default to the solid. It means you've got something wrong with your sketch, but you just go back and problem solve that. So 360 is what I'm after. Oh, okay, I need to type it in there if it's not going to do that for me. Whoops. And enter, and tick for green. That's looking good. The last thing then to do is just to add on the threaded bolt underneath. So it's back to PowerPoint. Okay, looks like we've got a distance of, I'm going to zoom in a bit actually. Looks to me like that says 58 to me, so we're going to go with 58. And also this information over here, which is important, it tells me that this threaded section is an M16 thread, which means M stands for metric, 16 represents the we'll call it the major diameter, which means that is the diameter from the outside of the thread to the outside of the thread, and 2 has to do with the pitch. We'll cover that a bit later on. 45 minimum length full thread. So that means from this end, from where the bolt would attach to the nut to where the thread stops, is a distance of 45. We notice that 45 is actually shorter than the length of the cylindrical section. So we need to draw a cylinder first of all, length 58, diameter 16, and then we're going to apply a cosmetic thread to that, M16 by 2 for 45mm long. So first things first, 58 and 16 on the bottom of our toe ball. So back to Creo. Here it is there. Let's spin him around. Let's put a sketch on the bottom. And some of you are probably saying, oh sir, why didn't you draw this when you did that revolve? For simple shapes like a cylinder, I find it easier just to do it in this mode. Sketch on the bottom, circle, and 16 it needs to be. Oh, it's pretty close. 16. Accept the sketch. Turn it sideways. Extrude a distance of 58mm and accept that. Okay, last thing to do is then to put a cosmetic thread onto this, not an actual helical thread as yet. So if we come up to engineering, I think it's under, it is, and click onto the cosmetic thread icon or menu, I should say. Now you can see over here it's got lots and lots of things that we can change, and it's asking whether there's red or this sort of pinky salmon color. It's wanting to know some information. The first thing it wants to know, what surface do you want to put the thread on? So if we come here and select this outside surface, you'll see that the orange lines appear from one end to the other end. That would be a full thread of 58, but our drawing said that it was only a full thread of 45, so we need to edit that. So we need to go to our next tab, which is depth, and you can see here it's selected a blind option of 58. If we change that from blind option, actually we can leave it at blind, sorry, but instead of being 58, if we make that 45, and we also need to select a surface where the thread starts from. So it's either going to start from the left end or the right end. So if I click in the box, come down here, I want the thread to start from this end, the surface highlights, I click on it once. And you can see now we've got a preview starting there for a length of 45mm and in that direction, which is correct. If that was the wrong way, we just click on that arrow and send it back the other way, but it's correct. The only thing that's different though is the actual diameter. It's defaulted to 14.4. We want ours to be 16. And in actual fact, I think if we chose other than a simple thread, if we go to standard thread, there we go, standard thread there, click on that icon there, and change it, leave it at isometric, and then we can scroll down here until we find an M16 by 2 thread, which is what we're after. Now that has applied an M16 by 2 thread to this cylindrical surface to a depth of 45mm, starting at that end. I think that's all we need to do. Surface, yes, happy days, and click. Nothing seems to have happened there, except when we view this in orthographic, in detailed drawing, we will see two thin lines either side of that cylinder, which represents that there is a thread there. We'll cover doing helixes at a later date. Okay, that's creating the toe ball. The only thing left to do would be to put some rounds or some fillets between the circle shape here. Back to PowerPoint, and if you have a look here, no information here, but you can see there's these little lines here which represent that that is not a sharp edge joining between the two of those. In an engineering sense, a sharp edge there between the two of them would cause a point of weakness, and you can see up here on the fillet detail drawing, it's a bit blurry, but we have a radius of 2 joining those two together and a radius of 2. So off to Creo, select that bottom edge, hold my control key down, select the top edge like so. You don't have to go right around, it's smart enough. Go to your round tool, type in 2, select OK, and happy days. Save it, and you're ready to start your next piece.